Hello, welcome to an introduction to special relativity. You might have heard of this guy called Einstein who came up with this. He was kind of a big deal, and based on his work, we will talk about some reference frames, which he didn't come up with reference frames, but he did then come up with two postulates for his theory of special relativity, and based on those, we can discuss simultaneity. First of all, a little bit of background to special relativity is you know something about reference frames. And a reference frame, ba-boom, is this. Somewhere where you can stand and you can take some measurements, like maybe the time, the location of an event, or maybe how fast something is going. The room that I'm in could be my reference frame, or you could be moving on a bus, and that could be your reference frame. A important designation, though, ba-boom, is an inertial reference frame. And we're going to say that that is any frame that you're in that is not accelerating, from which you could take some measurements. So with that in mind, maybe take a minute and are these four reference frames that I've drawn here inertial? Pause it, think about it, see what you say. Now if this guy is just standing here, yes, he's not accelerating very much. We're going to ignore the motion of the Earth. This bus, if it is moving at a constant velocity, then yes, it's an inertial reference frame. And that means there's no experiment you can do on that bus that would confirm the fact that you're moving. You can look out the window and you can see stuff going past, but maybe your bus is stationary and the world is just rushing past you. A Ferris wheel, no, it's in circular motion, so it would be accelerating inwards wherever you are at. A rocket, if it's on blast-off, no, because it would have an acceleration up. There'd be forces pulling you downward into your seat, so that would not be an inertial reference frame. Now here are the two postulates of special relativity. First postulate is that no matter what reference frame you are in, all the laws of physics remain the same. Write that down. The next one is that anyone within an inertial reference frame will measure light to be 3 times 10 to the 8th meters per second if they're in a vacuum. Write that down. Now you may think, well, that's not really that amazing a thing, but it gets a little weird when you get to the speed of light. For example, let's say that I've got a buddy Bob who I know can throw a water balloon at 5 meters per second if he's standing still. But then he's on some moving cart that's moving at 5 meters per second, and he can still throw the water balloon at 5 meters per second. Then I'm going to get hit in the head with a water balloon at 10 meters per second. That's going to hurt. If we're talking about the speed of light, though, let's say there's a crazy, fast, relativistic rocket that's traveling at me at 0.8 c, or 80% the speed of light, and it fires a laser cannon at my head. And we know that light's going to leave the cannon at speed of light, c. It's not going to hit me at 1.8 times the speed of light. I would still measure it coming towards my head at the speed of c, because it doesn't matter what the object that's emitting radiation, what speed it's going towards you, away from you, you're always going to measure its radiation as c, the speed of light. Now here's the two things you need to know about simultaneity. Maybe take a minute, maybe it's a lot to write, but just read these, see if they make sense. Now to help explain this, we have a very bizarre scenario. Let's say that you are just standing on the sidewalk looking at the street when suddenly a transparent bus starts coming down the street at 0.8 times the speed of light, or 80% the speed of light, and you actually have super slow-mo vision where you can actually see what's about to happen. Inside this clear bus that's moving past you in a moving inertial reference frame is the evil villain here, which is Purple Starman, and Red Power Ranger, and Blue Power Ranger. They are each going to fire their lasers simultaneously, at least from their point of view, and they are going to, they think, simultaneously destroy the purple evil Starman. Now we will ask the very important question that from the Ranger's point of view, from their reference frame, do they fire simultaneously? Let's assume yes. The Power Rangers are very well trained, so we can assume that they can fire at the same time. will they hit the Starman simultaneously? Yes, they're in an inertial reference frame. For all they care, the world's rushing past them at 0.8c, the speed of light. So if they fire at the same time, and they're the same distance away from Starman, from their point of view, yes, they will also hit him simultaneously. Now, from your non-Power Ranger stationary point of view, things are a little bit more interesting. You got to pretend that you were right even with Evil Starman when the bus was moving and when they fired towards the middle, which would have been essentially towards you from both sides as well. One of those signals is going to be moving towards you. One of those signals was coming from a guy who's now moving away from you. Since this one is moving towards you, you can think that it's going to get to you first. Since this one from the blue man is moving away from you, it's going to get to you second. So the answer is, do they fire simultaneously? No. Red will fire first. From your point of view, you have to measure that these things are traveling at the speed of light, and by the time you look at the blue man, since he's moved, it looks like he fired it from farther away, which is why it took longer for the signal to get to you. Another crazy part is that even though you saw red fire first, yes, they do hit Starman simultaneously. And the reason for that is because the red fires a farther distance, even though he fired first. That's because, from your point of view, you saw red man fire from back here, then by the time it hits Starman, maybe he's here. Whereas the blue guy, you saw him fire second, but he was back here. And it only has to travel this far, and you will simultaneously see them hit Starman at the same time.